Hello, everyone. Welcome to our next session of Open Security Summit here. I really happy again to be here and host this session. Our speakers, Petra and Michael, will give you a nice overview of our current topic, which is creating secure builds of containers. So with this, I'm passing them floor and enjoy the session and ask them as much as possible questions just so that we have very interactive session. Thank you.
Hi, everyone. So I'm just going to present myself and then Michael can present himself. And we're going to talk to you about containers and pods today. Now, for me, this was a new journey, like, pods, containers, Kubernetes, all very, very cool techie words. And, it was definitely worth diving into that techie/maritime world for me. So I'm going to give it, from my view, what kind of were the lessons learned from a project that we had in Glasgow. And then Michael's going to take you a little bit deeper and more granular into pod container security. So who am I? I'm the cybersecurity engineer at Glasgow. I'm a rookie machine learning enthusiast and Python enthusiast. Worldly maps enthusiast, that's how I got my job in Glasgow, by doing a worldly map. I'm a medical doctor by background, and I've spoken before on the Open Security Summit. I am a fan of DevSecOps, but still kind of like putting my foot into that ocean. So getting there. This is where you can find me on Twitter and LinkedIn. Next, please.
Hello, so I am Michael. I'm very happy to share with you this presentation today and work with Petra as well on putting all this stuff together. If you notice any accent, is because I am based in Costa Rica. So basically from my background, I am a software engineer and application security engineer. Basically, I led the OWASP chapter in Costa Rica from 2012 to 2020. I have been also involved on the developing of tools to detect advanced attacks following the current state of the cybersecurity and cybercrime. So I have been very involved on detecting and applying techniques such as machine learning and all the novel technologies out there to try to detect cybersecurity attacks and specifically to protect the small, medium companies around the world. I'm also a passionate researcher on cybersecurity topics, so I have been doing a lot of research on application security, specifically around topics such as dependencies on third parties. So this is a big topic right now, like how do we depend on libraries? For example, if you are writing code in Python, Java, Node.js, or even .NET, that there is a package management associated to that. So there is a bunch of actually a growing business out there on cybercrime trying to exploit this kind of dependencies. And we will talk a little bit about that in terms of containers. And here are, also my social media. I try to write a little bit at Medium and also basically my Twitter account. So we hope that you enjoyed the presentation and ask as many questions as you want. Okay, next slide.
Right, so one thing that we have to all remember, because sometimes we tend to get into this mindset because we're talking about containers and pods, we imagine them as being like, boxes that are like secluded and secure from each other, but we do have to keep reminding ourselves that, pods and containers are not actual sandboxes. They can leak and communicate with each other. So it's important to keep that in mind when we're dealing with them. It's important to limit the communication between our clusters because, we need to use the limited ports and we need to use network policies. Only the connections necessary for system operations should be allowed. I mean, this is kind of like the basic of cybersecurity, right? Like limited access. We need to remember to enforce TLS, encryption. If any man in the middle attacks happen or something, encryption is there for us to at least make the lives of an attacker more difficult. we should probably try and make our clusters not multi-tenant, because that way is more secure. If we, especially like I'm going to show you a vulnerability that's just occurred recently. But a lot of companies do try and make the clusters actually multi-tenant just because of it saves time and money. But for security purposes, we should try to aim to make them not multi-tenant. To avoid privilege escalation, make sure there's a pod security policy preventing privileged containers from running. Michael will talk a little bit more in detail about that. And container images should be run only from trusted sources. Next slide, please. So just to kind of wrap it up, put them in separate trust boundaries. You will see how that important is when you do a threat model of your architecture of your system. Don't forget to do a threat model. If you have like a big system in Kubernetes full of pods and clusters, make sure that you make your threat model, put them in separate trust boundaries, and see which pods can trust each other. And just remember, Kubernetes will not solve all your problems. Just because it's a cool techie word doesn't mean it will make everything go away. And hence the little comic here about just putting containers, like you don't solve a thing by saying techie things in Kubernetes. So yeah, just a geeky joke. And then carry on, next one.
All right, thank you, Petra. So basically, when we put together this topic, we wanted to cover a little bit of the current state of affairs, like what is in terms of containers, how are actually threat actors abusing from these kind of technologies in a way that can compromise organizations. And the truth is, as you read and investigate and research, containers are a hot target for threat actors. So we will see some of the items we have found. Specifically, as I was talking before, when we think on relying on third-party components, either libraries or even images that are hosted in the registry and things like that, definitely somehow we get into the A9 from the OWASP top 10, which is using components with known vulnerabilities. That means organizations need to do proper risk assessment before actually using components from third parties. And not only risk assessment, but also documentation, and make sure that those dependencies are up to date. For example, you don't really want to add a library that hasn't been supported for a long time. We had an experience a few years ago where we were using some software libraries that basically the author or the developer didn't push it very frequently, and we got some issues and had to do that by ourselves. So definitely, when we think in terms of containers, somehow we are actually talking about supply chain security, and we have seen really nasty attacks based on supply chain, right? Because from the attacker point of view, it's easier just go there to the registry or upload an image on top of that you can install and then start running malware or any kind of campaign. So we have put some information about that. Specifically is the growth of containers in particular. So we found a really interesting analysis from Sonatype folks. This is very recent from this year. So as you can see here, according to the stats available in the Docker Index, pools of containers images topped 8 billion for the month of January. That means that basically pools from the registry should top 96 billion this year, right? So as we see, there is a lot of activity happening when it comes to metrics in terms of the registry. So, I mean, from a threat actor point of view, if you want to compromise an organization, a good way is to actually start thinking on all the potential, risks and ways to compromise organizations via this method. And we have seen this already happen.
Michael, can I make a comment? Can you hear me okay?
Sure.
Yeah. So the thing that I have to say that I found worrying, right, was that when you guys were building the images, you still had to apply patches to versions that were actually the latest ones from the official distribution, right? Because I would expect official distribution to already be reasonably locked down, right? Yeah. So even forgetting about the other ones, right? Like just the fact that the latest versions are not as locked down as they could be. Like latest version of Linux distributions, latest version of particular tools is actually, you know, very eye-opening, right? Of how much, you know, we need to bake these into the pipeline, right?
Yeah, exactly. That's a very valid point, Dennis, and that comes to the point that even though you rely on original images from providers, you still need to do some hardening work, specifically to reduce the attack surface, and as you mentioned, is, you know, locking down the actual image. So you think about it, we found this interesting article from folks from Trend Micro, which basically talk about malicious DockerHub container containing images being used for cryptocurrencies, right? So what happens is a threat actor basically upload an image into the registry, and they are going to use typo squatting techniques. And by typo squatting, I mean using names that seems to be very, very similar to the original, even to the faint eye. You know, you work in security, you can easily, you know, just get the wrong image. And when you install that or run that stuff, what happens is your machine automatically, part of your deployment, starts you know, mining cryptocurrencies for other people. So this is something that we have seen in the wild in terms of, you know, containers and cryptocurrencies is a hot topic at the moment, and a lot of research happening at the moment as we are talking about. There is another one from Palo Alto Fox that says attackers cryptojacking Docker images to mine Monero. It's a very interesting read. I hope you had a chance to take at this stuff offline as well. And basically from this same analysis, what you can find is the image is created based on Ubuntu 16, the version. During the build process, basically the attacker installs some packages and builds them from source. And also based on the report and the aftermath of the analysis of the container, actually, the attacker were installing actually Tor. So with Tor, basically what they are trying to do is avoid any sort of detection. And after that, they were downloading this project, XMRig, which is for cryptocurrency mining. And then they actually deployed during the process a proxy chain. And then there is a Python command that is the actual responsible to start, you know, starting the actual mining process. So we can see this kind of thing when downloading this type of images without doing a previous security analysis or security risk. At the moment, many organizations that probably downloaded this image could be part of a campaign without actually knowing, right? So in a way, they are part of a big campaign, a big threat campaign, doing this kind of mining without actually knowing. And something important, which is very similar to what we have found, is actual security misconfigurations, right? So in this, another article says, misconfigured Docker service under attack by some malware. So what we have seen, and even what we were able to spot is, when you do a deployment of containers, specifically in Docker, you can do a security misconfiguration and exposing the API to the internet. So when you actually do that, what happens is anybody in the internet can run stuff in your infrastructure, right? So this is actually very, very important. This is what we have seen, basically a misconfiguration within the Docker API. As we can see, the attacker can start doing any other sophisticated attacks by exploiting vulnerabilities. And what we can see here is, you know, when we think in terms of threat actors, usually or traditionally, we have seen these, you know, focus threat groups or APTs, but also, you know, commodity attackers. So a commodity attack, if you do a security misconfiguration within your infrastructure, can very easily, you know, go to your infrastructure and compromise it. We will show you a little bit an example of this misconfiguration and how it's easier for an attacker to actually compromise, you know, the containers and everything running within your infrastructure. We will talk a little bit more about MITRE ATT&CK framework. MITRE ATT&CK is definitely one of the most consolidated data sources to describe how an attack, you know, the modus operandi of an attacker within a campaign. it is very important to understand, modus operandi, what kind of tactics, techniques are they using? Because if you have the big picture on how attackers can compromise your infrastructure, you can actually work proactively creating some sort of defense. So on top of that, yeah, let's talk a little bit about Docker security, container security. So when we were analyzing this topic, there are multiple ways where we can actually get a secure deployment. One of that is establishing a baseline for a Docker platform. I am here talking about Docker probably because it's the most wide known container platform, but also whatever platform you are going to use based in the OCI, you need to specify a baseline. I will talk a little bit more in detail about what a baseline is and why is that important. It's important that you limit your resources. For example, if you know that the application just needs, relies on JVM from Java and just requires, let's say, 1 GB of RAM to run upon doing performance testing, then that's a hard limit that you can establish for that image. This is important because if an attacker is able to access that particular container, he won't be able to actually use a lot of power from the infrastructure to continue compromise the organization, because you already have put some limits or quotas. Specifically, Docker daemon needs to be hardened and configured. There is a lot of security that you can do around the registry. And specifically, as Petra mentioned in the very beginning, is avoid to run containers as root, because that could allow an attacker to escape privileges and move horizontally within the organization. We also put together important elements when you are going to use official images versus unofficial images. And I am not going to say that unofficial images are bad, but you need to do proper risk assessment, right? So eventually, if you need something from an image that is not there, you need to do the due diligence and make sure that at least doesn't pose any security risk for your organization. We're going to talk a little bit about CI/CD and image security, because obviously we will need this to scale and be able to make sure that it's part of a continuous process for hardening and security. And more importantly, let's remember that on top of all this cool stuff of Docker, containers, Kubernetes, the ultimate goal for us is to run an application, right? But if we secure everything during the pipeline and the application we are deploying on top of that is vulnerable, for example, allows an attacker to do an attack such as remote code execution, that's it, right? That's the only element that you need to take into consideration. So the ultimate goal is to actually run an API or run an application, but we will need to make sure that this application is also secure, because otherwise, all the efforts we did in previous stages to make sure that the infrastructure is as much as secure as possible, basically it's not going to have any effect if the ultimate application is vulnerable. So a lot of considerations on top of this. So why it's important to establish a baseline, right? So establishing a set of configuration checks is important, to follow best practices. We can actually follow two main standards at the moment. One is CIS. CIS is the short for Center for Internet Security. These guys have been providing traditionally, guidelines and security, not only for Docker or not only for containers, but also for infrastructure overall in terms of hardening, guides of hardening within the infrastructure. And also NIST. I mean, NIST has provided this special publication 800-190, which is Application Container Security Guides, and provide an overview of the major security risks facing containers. So I strongly recommend you to check this out. I mean, to check this CIS. CIS even provides a benchmark. We will do a short demo in a few minutes to show how to use this tool and how you can benefit when deploying this kind of infrastructure. And follow this security standard. Always to have available a checklist and make sure that you are following this kind of application security guidelines. So what we did is we extract the CIS Docker benchmark. The current version is 1.2.0. And as you can see, the main elements or stages of this standard or this benchmark covers everything related to host configuration. That means what security elements you need to take into consideration from the host security point of view. The Docker daemon, then configuration files on top of the Docker daemon. Always containers, images, and builds of those configuration files. They also talk about container runtime, Docker security operations. If you want to run, in the case of Docker has a it's Docker Swarm configurations, and specifically, some elements for Docker, how to run Docker in an enterprise configuration. In the other hand, the NIST special publication, application container security, covers 5 main areas. As you can see, there is an overlap between both of them. This guy talks about image risks, specifically, those threats targeting images. It has to do with image vulnerabilities, image configuration defects, embedded malware, as we saw before, images that already contain cryptocurrencies mining, embedded clear text secrets, which is a big issue as well, that developers sometimes left, secrets or API keys hard-coded within the configuration files, and the use of untrusted images. On top of the registry, make sure that the connections are always secure to the different registries, stale images within the registry, and insufficient authentication and authorization items. In terms of orchestration, it talks about unauthorized access, fully separate inter-container network traffic, and orchestrated no trust. Also, in the container risk, you have some of them like vulnerabilities within the runtime of the software or application vulnerabilities. And last but not least, host, risk of the operating system host, specifically whether or not the host has a large attack surface exposed, the shared kernel, improper access, and things like that. So as you can see here, both the standards actually cover very similar of the items that you need to take into consideration when deploying this thing into production. And it's always a good thing to take a look at that. I strongly recommend you to double check them. One of the probably security recommendations that we were talking earlier is about resource limits. In this case, reliability.
Michael, sorry to interrupt. I saw Klaus has a question. It says, you mentioned CIS for Docker. So now with the it's dropping support, now that Kubernetes is dropping support for Docker and keeping only containers, you'd use another one?
That's actually a good question. I haven't seen from CIS any documentation around that. It would be good to take a look at that actually, because that information is useful. Thank you. Even though what you can do is actually use the best practices or recommendations from the actual security standard, because most of them applies to any container schema or infrastructure. Like things like never run containers with root accounts and things like that. I guess you can still get benefits out of that. So yeah, when we were talking about resource limits, is how you can beforehand, before deploying this thing to production, you can actually know what is the recommended limits to applications. As I mentioned before, the example with the JVM, if we already did reliability and performance testings, we know what is the adequate limits of resources that our container is gonna need to run. You can define those. And why is this important? It's because if a container gets compromised by a threat actor, there are proper resource limits set up in a way that they are not able to use large amount of resources by using that. In the case of Docker, that's possible to do via C groups, where you can actually establish limits for memory, CPU, network, and storage. And OWASP has created a quite interesting documentation called Container Security Verification Standard, CSVS version 1.0. And at the moment, as you can see here, they have a really good amount of checklists about items, for example, security verification requirements in terms of verify that airbag model manage access control use. So this is something that you can take a look as well. Verify, for example, that SSL and TLS certificates are being used. So it's important to take a look at these, security verifications just before go into production. You can do a checklist of these things, for example, to make sure that you never have secrets exposed or sensitive information such as APIs or passwords within the configuration files that can be leaked and used by a threat actor. And not only compromise the infrastructure, also the cloud infrastructure where this infrastructure relies on. In terms of the container security verification standard, what we did is we tried to put together some of the main stages or areas that this standard used. For example, you may have items related to the organizational infrastructure, containers, orchestration management, image distribution, secrets and keys, network storage, logging and monitoring, integration, disaster recovery, and testing. Logging and monitoring is crucial, right? So as we are deploying infrastructure and applications into production, we need to have an eye into what is happening in terms of monitoring, right? What is the behavior? What is it happening? Everything needs to be logged and centralized. So I strongly recommend you as well to take into consideration this standard for you to take a look at the how to enhance and level up the security bar of your deployment. More importantly, containers are not run as root, right? So this is tell us about the least privilege principle. It's better saying than do it, I know, and we have seen, that people run applications as root. So the problem is of doing that is, let's say you are hosting an application running on .NET Core or Java or even Node.js. If that application poses any potential vulnerability that allows an attacker to run a remote commands on top of that, and if the process is actually running as root, he will be able to, to scale or to move to other infrastructure and start escalate privileges and move laterally through the organization. So it's always recommended never run the containers as root. Well, configurations of the Docker daemon, if you take a look at that, there are some good recommendations about that. For example, make sure that it can be configured on HTTPS. And what is important about that, I will do a demo after this using the Docker Bench Security. As you can see here, you can apply a specific check, and what it's gonna check actually is to see if your deployment uses, how is the actual Docker daemon deployed, which is very important. Well, Docker security in the registry, that's an important item. Even if you use, the DockerHub or your own hosted registry, it's important to make sure that self-hosting registries are protected. Make sure that the communication between client, the Docker daemon, and the registry must be secured using TLS. This is relatively easy to deploy using things like Let's Encrypt. And it's important to protect the registry using, obviously, basic authentication is quite basic. It still is a protection. A token-based authentication via, for example, reverse proxy. So there are multiple ways for us to protect the security registry. The worst case scenario is that somebody can go there and have access to that registry and contaminate the images on top of that. So when you install them, basically you are actually promoting the distribution of ransomware or malware within the organization. More importantly is that we can integrate a lot of tools within CI/CD and have very easy feedback. So at the moment we have been using some vulnerability scanning tools to scan data. As you can see here, you can configure these tools with things like with GitHub Actions. So what happens is the Docker action triggers and scan within the image that you are created, and you can see, for example, after running this, we were able to see a lot of vulnerabilities on top of that. Actually, 287. I don't know how to hide this guy right here, but this is a report of the tools being happened or being used within the CI/CD using GitHub Actions. Then it's important, multiple organizations have multiple requirements. Usually when it comes to infrastructure and deploying operating system, we need to be compliant depending on the industry you move on. For example, if you are working in finance, probably you need to be compliant with PCI DSS or HIPAA and other regulations around the world. It's better or it's recommended to have a hardening process on top of that. Actually, you look at the CIS, these guys already provide hardened Docker images that you can run in multiple cloud providers, including AWS. So what they do is, they take a base operating system such as CentOS or Ubuntu, and what they do is they run a hardening process to remove and reduce the attack surface. And a tool that we have been using this in the past is called OpenSCAP. OpenSCAP is an implementation of the open source specification of SCAP. SCAP is Security Content Automation Protocol. Basically, it's a set of best practices you can apply to an operating system. For example, let's say you want to create your own images out of CentOS 8 or CentOS 7. You can apply multiple compliance checks. For example, there are a SCAP for security compliance, for PCI DSS, even for Red Hat security. What happens is when you run these tools within the base operating system, they can actually do remediation. So the tool allows you to make sure that the image itself is secure, and then you can export this as a container image, which is a best practice on top of that. So I strongly recommend you to take a look at OpenSCAP. This is an open source project actually, and they are continuously changing and enhancing the multiple checks or security checks to be compliant with that. So even so, I mean, you think about it, even so you don't need to comply with PCI DSS. We are very sure that PCI DSS provides really good security recommendations. So it's good to follow them, not as a compliant, but as a security best practices. What do they say about how to manage passwords, accounts, password resets, users, and things like that. Those are, security best practices that we can backport and create our own resources without needing to be compliant with them. Even though we are not in the industry that requires us to be compliant, we still can backport the best practices. I guess that's the main issue. And vulnerability assessments, we have paid applications. For example, you may have a SNCC, you have Qualys. I put together here some of the tools that we have been using from the open source community. One of that is Trivy. So Trivy is not only for images, it's also used for applications and dependencies. We actually added also Clair. So Clair is very interesting because this tool is an open source static analysis scanner. So basically it analyzes all the layers of a given image and try to identify potential vulnerabilities. And also the Docker Benchmark for security, which is a best practice around deploying Docker container in production. So in terms of Trivy, so Trivy is a comprehensive vulnerability scanner for containers. The good thing about this tool, as we have been using it, is that it's compatible in the DevSecOps and shift left approach. So we can integrate that with Travis, with Circle CI, with Jenkins, with GitLab CI. It detects vulnerabilities on the operating system, from Alpine, from CentOS, from Oracle, from Debian. And it's very simple to use and fast to use, right? In the other hand, we have Clair. So Clair is a Docker static analysis scan. So allows, I put Docker in here, but also supports OCI. So even though you are not reliant purely on Docker, it also supports OCI. So it parses image contents and reports vulnerabilities, affecting the content via static analysis. So static analysis is a good thing, it's very interesting. I need to be fair, the deployment of Clair is a bit more complex than deployment of Trivy. Trivy is basically a tool that you just run. This requires a little bit of setup, but if you have an engineering team, this can be built and be added within the continuous integration as well. And let's do a quick demo of how to use this thing. So let me stop my screen and just actually showing. Please bear with me a second. In the meantime, I'm not sure you have any questions. Okay, let me share my screen. Okay, so this is a machine that we have. Actually, let me see how can I move this in. Here. Okay, so we have a Ubuntu machine on top of this. We have some tools here in the OPT folder, and the first thing I'm gonna do is to run the actual Docker Bench for security. So this is a tool that you download from GitHub, and basically this scan, tries to do a lot of things and analyzing the multiple layers that I showed before within the diagram. This should be very easy to run. So as you can see here, it provides a nice report. The report checks things like general host configuration, Linux host specific configuration, and in here you can see that ensures a separate partition of containers has been created. In my case, I don't have it like that, so it has been scored. You can actually see recommendations for the Docker daemon configuration. In this case, ensure network traffic is restricted between containers as default bridge. This is scored because I don't have it like this. This can give you a good picture on how to, how to host this kind of thing. They also check, the Docker daemon configuration files. And basically the multiple checks that I showed before within the mind map that I had previously. It's gonna tell you, the good thing about that is it's actionable. Unfortunately, this benchmark doesn't apply remediation, but at least gives you a way on how to fix that, or at least it's telling you what is the security issue that you have, and you can enhance between that. So this is a tool that I recommend you to use for multiple checks. In the other hand, we have Trivy. So let me go back to here. So for example, and this is something that Dennis was mentioning before. Sometimes when we scan an image that we just get from the official sources, it poses some vulnerability. So in this case, Trivy is very easy to run. So you just need to provide the multiple severities that you want to filter out. You might have low, medium, high, critical. In this case, I am just focused on vulnerabilities that are high or critical. And I am gonna analyze the NGNX image in this case, right? So you run this scan. Basically, it's gonna do an analysis on the multiple dependencies. So what this tool does is list all the dependencies that this image potentially has, which is good for asset management and asset inventory, and also actually tells you the multiple vulnerabilities that you have in here. So as you see, this is a brand new image that I got from the registry, and it has some high security vulnerabilities, and it provides you a CVE associated with that. In this case, what is interesting about these findings is still they don't have a fixed version. So still this vulnerability hasn't been fixed about that. And probably you just need to be aware of potential false positives. When we use tools, chances are that there still are false positives within your evaluation. But for example, take a look at how different it is to run that against NGNX than against Alpine, right? So Alpine is a very small distribution. So in this case, the image is very small and actually doesn't poses any vulnerabilities as per this scan. So if we are about to build our own images, it's a good recommendation to start small. Maybe you can use a base image of Alpine, and as you can see here, Alpine doesn't pose too many security vulnerabilities. And the other tool that I wanted to show you as well is Clair, right? So to do that, I need to get into the repo. So let me go to the Clair scanner, and in here you can run, an scan like this. So on top of that, there is an executable, command here called Clair. You need to specify the IP of the server. That's why I tell you before that deploying or actually setting up Clair is a bit more complicated, because actually you can have that in a separate server to run this stuff. I have everything here locally. And what I'm gonna tell you, Clair is, please scan NGNX and let's generate a report called NGNX demo report, right, in JSON format. So this is gonna start the Clair scanner, right? It might take a few seconds to complete. Let's wait that to finish. And here you have a totally different view of this image particularly. So as you can see, not only shows you the libraries that are affected. So in this case, this says this image NGNX contains 104 unapproved vulnerabilities. Basically, this library live XML2. This is the package version being used, and this is the CVE of the vulnerability. And you can see here that there is a potential description. Now we will need to make sure how do we patch this stuff, right? Do a proper risk assessment. Okay, we are gonna use NGNX image. Be informed that you are gonna rely on these vulnerabilities. Okay, now we will need to do a proper risk assessment and identify, yeah, I mean, but what is the worst case scenario? If somebody is able to exploit this CVE, what happens to my organization? You know, what is the threat vector? But at least gives you an idea of multiple potential vulnerabilities associated with the current version that this image came with. And this is something like what Dennis was saying before, is that we have seen that we just get an official image from the registry, and out of the box, when you run a scan, automatically contains some security vulnerabilities. Some of them have been patched. Some of them you need to update the operating system, the underlying operating system, to patch them. But whenever is the case, you need to be aware of what are those potential vulnerabilities. Definitely do some analysis and make sure that those are not, you know, false positives in a way, and make sure how they affect you, right? So this is very important. So I strongly recommend you to start doing this kind of analysis to have a good idea and visualization of the tools. Last, before we continue to the presentation, take a look at this. I am not sure you're still seeing my screen, but the problem with security misconfigurations is, you know, you can use a tool like for example, Showdown. With Showdown, you can take a look at potential misconfigured Docker deployments. For example, you may see who has this port, which is the API port exposed for Docker, and you can see many IPs. Probably some of them are, you know, honeypots that you can use it, but effectively an attacker can run an image into this exposed stuff. So be aware that if you left a misconfiguration within your deployment, a threat actor and an attacker can use multiple tools to actually, you know, compromise your organization, as simple as doing a search or using the internet to scan that. Okay, let me go back to the presentation. Can you see it? Actually.
Yeah.
Okay.
We can
okay,
see.
Thank you. Okay, so the next or the second part of this presentation, we wanted to put together some information about Kubernetes security. So basically, you know, there are 5 elements that we are concerned when it comes to Kubernetes security, probably more than 5, but obviously default configurations needs to be proper assets, you know, just to make sure that we always run on a first least privilege. This privilege is key when deploying, you know, infrastructure in this kind of technologies. Also, container runtime. Just remember that Kubernetes out of the box doesn't provide any sort of prevention or protection actually against attacks in the runtime, or cannot detect any sort of intrusion. So we will need to make sure to have proper monitoring and things like that for detecting, you know, intrusion. Also, images is the same issue we have been talking about. Poorly configured images allows an attacker to break into the network. That's the case, right? I mean, if the underlying image poses a potential vulnerability, could be potentially exploited by an attacker. Host configuration and pod-to-pod communications, right? So by default, again, Kubernetes does not provide a network security policy to each pod or to pod-to-pod communication. Actually, when you implement this kind of policies, they act as a firewall. So it really depends on how you are gonna, you know, how the application actually looks like, where you can start establishing some sort of pod-to-pod policies for preventing this kind of attacks. And this is important. We found that there is an actual CVE. This issue is open. It's actually open. Basically, Kubernetes is prone to a so-called main in the middle using load balancer and external IPs. And what is important about this CVE, when you look at that, is a insecurity by design. So it's the way Kubernetes is designed that allows you to, to be prone to this CVE. There is a good description about that, so you can take a look at that offline. That would be great. But basically, a security issue was discovered with Kubernetes affecting multi-tenant clusters. If a potential attacker, can already create or edit services and pods, then they might be able to intercept the traffic from the pods to pods. So there is a potential way or avenue for an attacker to do man in the middle by using this kind of configuration.
Can I just add, sorry, Michael, can I just add about this vulnerability?
Sure.
It's also important, like with any other vulnerability, to do a risk assessment. So like if you see this vulnerability come up and you have systems in Kubernetes, it's important to see, are those systems actually multi-tenant? That's one thing. And the other thing that you can do is just lock down those pods, like lock down the access, limited access, do IP whitelisting. For example, we were thinking you can implement that only people from a certain VPN can access those pods. Also multi-factor authentication. That way you limit the access to the pods, because to actually exploit this, you need to be already a user with some basic permissions. So, there's a couple of things that you can do in regards to this vulnerability, and that brings it down to quite a low risk at the end of the day. And it's just like with any other vulnerability, it's important to do that risk assessment. And also, if you cannot make your clusters, not multi-tenant, then there is that option of do event monitoring. So you can set up a SIEM and monitor what, if there's anything, if there are any events with external IP addresses happening, that could kind of indicate that you're under attack, that someone's exploiting this. So there's a couple of things that can be done in regards to this.
Exactly, great provision.
Sorry, I just want to say that, in addition to what Petra said, as there is no live solution at the moment for this, so by Kubernetes, there's no security patch. So the best thing to do is to go and to lower the risk. I meant getting all this whitelisting stuff is not enough, because what I discovered where I was doing some testing, that when you authenticate with a Kubernetes cluster, it has nothing to do with. So first thing to do here is to minimize the risk. Probably just make sure that users has enough permissions, just do enough privileges and minimum privileges, and not extra privileges. So, but I mean, in this situation, there is one big security hole here, where whether you were on AWS, hosting Kubernetes on AWS or on Azure, which is if you
public cloud.
If you, when you try to connect to your Kubernetes cluster, you download that configuration file to your machine. So that configuration file, if you have it, you will be able to connect to your Kubernetes cluster, whether you have MFA and other stuff, and MFA and whitelisting or not, because it is independent from that, unless you go and specify, just go and implement something like role-based access RBAC on your AWS or on your Azure. And that's the only way you can minimize it, is to just limit the access here. I know that, to download the Kubernetes configuration file to your machine, at the first start, you need to be like a part of that solution. You need to be able to connect at the solution for one time. But as soon as you have that, you don't need a VPN to connect. So there was a lot of work around on this one, just to minimize the risk, because, as we know, we don't have the solution. One of them I was thinking, which I was telling Dennis, I saw it as a hack more than a solution. So if you have corporate machine, maybe you can put a script, push it via Intune or group policy, and say on startup, on log off, on log out, just go and delete that delete that .cube folder, the configuration file basically, and on startup just reissue that. But I see that as a hack. So hopefully we'll have a solution for this as soon as possible.
Yeah, thank you, Abbas and Petra, for the contribution. When we actually were investigating this, all the security elements of Kubernetes, we come up with a project that Microsoft created actually this year as well. Basically, what Microsoft team have done is they have created this MITRE ATT&CK framework based on risks associated to Kubernetes. So what they realized, I'm sorry, is that even though it's a very different, at the moment, if you look at the MITRE ATT&CK framework, is for operating systems such as Linux, Windows, and basically the MITRE ATT&CK describes the multiple ways on how an attacker compromise an organization. Let's say, I believe the dwell time is now like 1 week or so. So in 1 week, a potential attacker can get into the network and gain access to the Active Directory, for example. So they have described the modus operandi of an attacker. Why? Because multiple campaigns, of ransomware or threat actors like APTs, they behave the same way, because behavior is something that is very hard for an attacker to change, specifically because they have spent resources and time to use this kind of thing. So the MITRE ATT&CK in a way describes what is the modus operandi of a threat actor within your network, aiming to impact the organization. So you think about it, what these guys did from Microsoft is they say, look, even though the techniques an attacker uses in an environment such as Kubernetes is very different from a Windows environment, the techniques are very similar. For example, an attacker still needs to have initial access to the cluster. Once the attacker gets initial access to the cluster, he or she needs to actually execute commands on top of that. Then the attacker within the cluster needs to have persistence. So eventually, if they are discovering one of the nodes, they have persistence in a multiple nodes. They really want to do privilege escalation. They want to do defensive action to detect, to evade any sort of defenses. And how can they do that? For example, they can clear container logs. And that's why monitoring is important. If we have a solution that is actually pulling out the multiple container, logs, even though the attacker removes them, we can actually have centralized and analyze the behavior. They can actually delete KA events, post-security. For credential access, obviously, they are going to try to list the secrets into the KA. Accessing the Mount Service Principal. In terms of discovery, they are actually going to use the Kubernetes API for doing that, using network mappings or actually metadata. And then they are trying to move laterally in the organization. How they do that? Well, actually using clustered internal elements and multiple stages, right? And at the end of the day, the actual impact for the organization is either data destruction. For example, depending on the campaign might be attempted to actually destroy data, or hijack any resource in the case of crypto mining, or perform any sort of denial of the service. Things like, for example, be part of a botnet and things like that. So I certainly recommend you to take a look at this analysis that Microsoft has created that explains, because if you think about it, having these measures, you kind of start thinking on multiple threat models and actually countermeasures, right? How do we prevent initial access from my organization? Because eventually the attacker wants to have access to my Kubernetes cluster. So there are some specific techniques that the attacker uses to gain access to the cluster, for example, like that. How can I put, proactively add some sort of countermeasures or actually monitoring or early detections that allow me to identify this sort of, behavior. That's very interesting from a, defensive point of view to understand multiple ways on attackers can compromise these things. Somebody was drawing things here. I'm not sure who was, but I'm not sure the idea was to highlight some of the important items within the matrix. But yeah, somebody was playing with the diagrams.
Sorry, Michael. That was I was actually trying to zoom out. You know, for some reason my phone went to the annotate. What we need now to do, this is brilliant, man. What we need to do is now put this into a graph, right? So we can start to connect the dots, right?
Yeah, exactly. Yeah, this usually, you know, because I have been working a lot within the detection point of view, the blue team point of view. What happens is exactly you put this thing as a graph, and you can come up with a matrix or risk matrix based on different, you know, attacks and where you want to focus. Probably you're gonna say, yeah, I'm gonna focus on leaking credentials, right? So I can cover this guy. I have actually a tool that actually checks that configuration doesn't pose credentials and access. So you already have this covered, right? And you can see what percentage of the actual metrics you have coverage. And the idea is that this is a continuous and evolving process, because at the moment we have, I believe there are like 30 different techniques, but probably in 1 year from now, looking into the statistics and the continuous usage of Kubernetes, probably we're going to have more like that. So you can expect this to evolve into something more complex even, right? So
we could even do a wordly map on this.
Yeah.
Well, that's the idea, right? Like if you think about it, right? Like what wordly maps give you when you, especially when you are creative with the evolution scale, is it starts to allow to put things into perspective, right? Like for example, like which ones you're going to focus on. Like for example, if you think about it, like this is a chain, right? Like this is a sequence of events. So actually, it's almost like the anchor could be on the left, right? And then it follows a particular path, especially if you kind of build it like an attack tree, right? Then the interesting question is, which ones should we focus on, right? Which ones are dangerous? Which ones? So the wordly mapping, you know, depending on the risk or depending on, for example, where it comes from, there's multiple ways that we can basically map the evolution that will allow us to understand, you know, the key questions: which ones to outsource, which ones to develop, which ones to buy, which ones to risk accept. You know, give us from that landscape, right? That situation awareness.
Exactly. Yeah. You know, when you look at the MITRE attack, because this one for Kubernetes is awesome. I mean, I think these guys did amazing work doing that. When you look at the multiple metrics that they have on top of that, the question is, where do I start? Because probably you have in here 30, but for other technologies, you might have 400 different techniques. You know, probably you may focus on which one of these causes more impact to the organization. So probably lateral movement is one of those, very critical. But actually, you can start being proactively, like putting some countermeasures within your process to try to identify when secrets are being leaked, right? When configuration files create APIs or you know, tokens that can eventually allow an attacker not only to have access to the Kubernetes cluster, but also to the cloud infrastructure in the public cloud where these guys live, right? So this is the idea. I mean, I guess it's good to put an eye on this and see how can we proactively start implementing
Michael,
measures.
You also want to map, right? Like for every vulnerability or every risk you have, where does it relate to this, right? So then, because the other thing that, you know, we have to, for example, so even when you say, for example, visualization and logging, right? If you have access to, you know, the side effects of those exploitations, it actually means that the risk is lower because you can detect it. So like the biggest concern I always have is not necessarily about a vulnerability, but is whether the security team or the SOC team can detect it. Because if you can detect it, you can do something about it. The problem is when you can't detect it. Oh, by the time you get it, it's too late,
it's
right?
Too far,
So you know, and that's what you get. So that's a good example of a wordly map. Like we could say, if you put on the left the ones that we can't detect at all, the ones on the right that we can detect very quickly, you start to see which ones you should care about.
Exactly.
Which is the ones on the left.
Yeah, definitely. Definitely. And in terms of monitoring, as you can see, even though the attacker is going to clear the logs, you already have a control to collect those logs, and you have some rules to actually detect. You know, I'm not sure what is the actual event that happens when somebody clear a container log. If we are able to spot that, we can flag it as a suspicious activity, because under normal conditions, I mean, why you would clear this kind of logs? You know, unless there is a maintenance task.
I will go even a step further. Right? I would say a log detection event is a major incident immediately, right? Because There is no normal. Remember that you're also going to have data to support it, right? So if you have no data, doing our testing, doing our development, that, for example, clearing a log is a regular occurrence, that means that you now have a very high fidelity signal of something bad happening. And it's either basically a major bug that, again, should be dealt very kind of, thoroughly, or is an incident, right?
Yeah, exactly. But so something that needs to be evaluated anyway, because, obviously, you need to see what is the impact of doing that, and eventually you need to double check if that's normal or that's a suspicious activity, right? But yeah, I totally get the point. Yeah, that would be interesting to put that into the context of this kind of mapping.
That's why we have a security incident team, right?
Yeah, to get back to the community with a different point of view about these metrics, which is really good. Great. So what I did here, or I tried to do here, is just to put multiple elements. For example, in the initial access technique, basically the attackers try to gain access to a resource, which is a Kubernetes cluster, and they can compromise cloud credentials from public clouds, and could lead them to a cluster takeover, compromise images within the registry. A compromised image can compromise the cluster, since attackers will registry access can implant their own attacks. There's a typo here, but yeah, you get the idea. What I try to put together is the multiple stages within the life cycle of an attack, which is pretty much what you can find in the matrix, right? So I strongly recommend you to take a look at that matrix and see if we can make that available in multiple visualizations or in multiple graph-based approaches with countermeasures. That would be great to have a countermeasure point of view about that. And the impact, obviously, as I was mentioning, the ultimate goal of the attacker could be like remove or steal information, or destroy or hijack or deny of the service. And yeah, just to sum up, final recommendations. It's necessary to always perform vulnerability management of the image scanning and image hardening process. Specifically, that's where you are going to deploy the multiple applications. It's important to integrate this kind of vulnerability management within the SDLC, right? Via CI/CD pipeline, so it's more proactive. It's more, the feedback is more accurate, is faster. Always enforce least privilege in every single infrastructure. Take a look at the default configurations. The fact that this default doesn't really mean it's secure. So make sure that the stuff is not being deployed using default configurations. Take a look at the OWASP container security verification standard, which is a great checklist from my humble opinion. Ongoing centralized collection of logs, that's important. That's what we have been talking about. And then implement some sort of alerts or detections on top of that collection of logs. Continuous monitoring of your Kubernetes cluster, and always check default configurations, right? So that's pretty much what we have today. At this, I know it's a bigger topic. You can go deeper and deeper and deeper. Kubernetes itself is their own topic, but we wanted just to put into context, like the current state of affairs, how attackers is compromising organizations, what are some of the common security misconfigurations, and how to avoid them. And particularly, that there are tools available both from the open source and paid. I didn't cover, Qualys and Sneak and all the, production ready, let's say, paid applications that you can use, but there are too many alternatives, right? It's just a matter of start implementing them within the cycle to make sure that the applications are even more secure, right? So I really appreciate your time, and hope, we were able to provide some recommendations. I'm not sure if you have any question or comment, but I really appreciate your time.
Yes, thank you everyone for joining, and thank you Michael, Petra, and Abbas also your involvement, and really great session. So we are a bit out of time, but if audience has some questions, Michael and Petra still are here. So any more questions to Michael, Petra?
I have a question. Michael, Petra, is there a Kubernetes security project out there?
That's actually a good question. Yeah, I didn't find it anything. Really didn't look at that very deeply. We can double check and get back with any finding. If not, we can start up one. Why not?
Yeah, because I think there was the Kubernetes or the container top 10, right? But I think it would be interesting to see if there's actually a Kubernetes security project, because there's also so many now tools and ways to secure it, right? That you kind of want to consolidate some of that, right?
Mm-hmm. Yeah, I will take a look to see and do a deeper analysis to see if there is anything like that. Then that's a good question.
Cool. Yeah, let's plan a number of sessions for the next January event, right?
Yep.
Around Kubernetes security.
Security and authentic, like, in terms of authentication and stuff like that, and how can it work on different platforms, and how can you secure your Kubernetes clusters? I think that will be a very good in the future session, and I'm more than happy to help on this.
I do agree. Mm-hmm.
It's just exciting, to be honest. I was working on that yesterday, and it's just really cool. So
perfect. So we even have volunteers to do next sessions in January with Michael and Petra. Thanks, Abbas.
I meant in the background.
No, we will have the focus just on you. Okay, thank you, everyone. Any other questions? If not, then really thank you. And this is one of the last sessions, I think, for this phase. So we are looking forward on January, and please continue.
No, there's one more. No, I think there's one more Open Security Summit session about SEMGRAPH.
Yeah, one of the last sessions.
One of the last. Okay.
Thank you, everyone.
Thank you, everyone. Yes,
Thank you
and meet
very
you
much.
there.
Thanks, everybody.
Thank you.